You know, I've been in a lot of meetings, committees, panels, review boards, faculty lunches, you name it. And I noticed something strange, something that bothered me for years before I could put my finger on it. There's a particular kind of person in those rooms. Smart-sounding person. They use big words. They use important words. The sentences are long. The pauses are confident. Everyone nods. And yet, when they're done talking, I have no idea what they said. None. Zero. Not a thing. And the fascinating part, the really fascinating part, is that nobody else in the room seems to notice. They just nod along. And then somebody asks a question, and the person responds with more words. Equally impressive, equally long, and equally empty. Now, I'm a physicist. My job, my whole career, has been to figure out what's actually going on beneath the surface of things. When I look at a magnet, I don't just say, it's magnetic. I want to know why. What is the mechanism? What happens at the level of the electron? What is the precise nature of the force? That habit, that itch to get beneath the surface, it turns out, is exactly the tool you need to spot someone who sounds smart but isn't clear. And that's what we're going to talk about today. Let me tell you something about physics first, because physics has a way of cutting through nonsense. When I was a young man studying at MIT and then at Princeton, I had this game I played. Whenever I read a paper, doesn't matter how prestigious the journal, doesn't matter how many fancy credentials the author had, I would try to translate every sentence into something I could actually picture. A mechanism, a number, a process I could visualize happening in space and time. And here's the thing, most papers survive that test. Good physics papers. You can do that. You can picture the electron moving. You can picture the photon being absorbed. Maybe the picture is approximate. It always is, in quantum mechanics especially. But there's something there, some actual content you can point at. But some papers, when you tried to translate them, you got nothing. Not hard to understand. Not requires more study. Nothing like translating a sentence into another language and discovering there was no sentence there to begin with. Just the grammar, just the shape of a sentence. That's what I mean by sounding smart without being clear. Think of it this way. Imagine I told you the ontological substrate of temporal continuity manifests heterogeneously across modal configurations of experiential awareness. Does that mean something? It sounds like it means something. There are nouns, there are verbs. There's even a word like heterogeneously that makes you think maybe there's some technical precision in there. But what does it mean? Nothing. Absolutely nothing. Now let me say the same nothing in plain English. Time seems different depending on your mood. That you can check, that you can examine. You can say, is that true? What's the mechanism? Does that hold up? The moment a sentence becomes clear, it becomes checkable. It becomes something you can argue with, confirm, disprove, and that's the tell. That's the first signal. Now, I called this, at least in my own head, the translation test. And it works like a charm. The rule is simple. If you can't translate what someone said into a concrete example, a picture, a number, or a process, then either you don't understand it yet, or they don't. And here's the uncomfortable thing about that rule. Sometimes the problem is you. I don't want to pretend I always understood everything I heard. Sometimes I'd leave a talk and realize I'd missed something. That happens. That's fine. You go home, you study, you come back. But there's a difference between not understanding yet and there being nothing to understand. The way you tell the difference is, go to the speaker, or go to the textbook, or think harder and ask, can anybody translate this? Can anybody give me an example? If nobody can, not the author, not the professor, not the expert in the room, then there's your answer. There was nothing there to begin with. I remember once at a philosophy conference, and look, I have nothing against philosophers. Some of my best conversations have been with philosophers. But I was at this conference, and someone gave a talk about the nature of consciousness, and they used a phrase like qualia manifesting in phenomenological space. Now, I'm curious. I always am. So after the talk, I went up and I said, that's interesting. Can you give me an example? Like a specific one? What does that look like? The response was about 15 minutes long and contained 0 examples. That's the tell. Compare that to the best teacher I ever had, not at university, but a teacher from when I was a kid. My father. My father was a uniform maker. He had no formal education in science, but he had this remarkable gift. Whenever he explained something, he explained it in terms of what you'd actually see, in terms of process, in terms of this happens, and then this happens, and then that happens. When he explained how birds got their color, this is when I was very young. He didn't say, due to biochemical pigmentation processes and structural coloration mechanisms. He said, look at the feather. Now tilt it. See how the color changes? That's because the color isn't a dye, it's the structure. The light bounces off the little layers and interferes with itself, like ripples in a puddle canceling each other out. That is being clear. You can check it. You can tilt the feather. You can look okay. So we've established the symptom. Now let's dig into the mechanism. Because I'm not interested in just telling you that the disease exists. I want to know how it works. What's the physics of intellectual fog? There are a few reasons people end up sounding smart without being clear, and I think it's worth going through them carefully, because some of them are innocent and some of them are not. This is the most straightforward case. Someone doesn't understand something deeply enough to explain it clearly, but they've absorbed the vocabulary, the style, the feel of the field. So they produce language that pattern matches to real expertise without containing real expertise. This isn't always dishonest. Sometimes people genuinely think they understand something and they don't. I know that feeling. I've had it. You read something, you nod along. It feels familiar. You think you've got it. Then someone asks you to explain it, and you realize you were just tracking the shape of the argument, not the content. The test I use is this. Try to explain it to a freshman, not a graduate student. A freshman, if you can't explain it in a way that a bright 18-year-old can follow, then you don't understand it well enough yet. That's not an insult. That's a diagnosis. Go learn more. Now, here's where it gets interesting. There are things that genuinely can't be explained simply because they're genuinely complex. Quantum electrodynamics, for instance. The full machinery of renormalization. You can't explain that to a high school student in 5 minutes and have them understand it rigorously. That's not fog. That's genuine technical depth. But, and this is important, you can always say what it's for. You can always give a concrete example of what it predicts. You can always say, the theory tells us that the magnetic moment of the electron is this number, and when we measure it, we get this other number, and they agree to 10 decimal places. That's concrete. That's real. That's a thing you can hold. Vague language is safe. If you say nothing clearly, you can never be clearly wrong. If your prediction is fuzzy, it's never falsified. If your explanation has no specific mechanism, no specific prediction, no specific example, then nobody can point at the data and say, you were wrong. I think a lot of intellectual fog is, at its core, defensive. It's the academic equivalent of keeping your head down. You produce enough impressive sounding language to satisfy the reviewers, to satisfy the committee, to get through the meeting, and the fog protects you from accountability. This drives me absolutely crazy. In physics, if your theory predicts something and the measurement disagrees, the theory is wrong. Full stop. The universe doesn't care about your tenure. The universe doesn't care about your reputation. It just is, and your job is to figure out what it is. The willingness to be wrong. The willingness to make a clear, checkable, falsifiable claim. That is the mark of real intellectual engagement. The moment someone retreats into language so vague it can never be wrong, they've left the conversation. They're no longer doing anything useful. We've trained audiences, in universities, in corporations, in culture generally, to reward sounding smart, independent of being clear. The longer the word, the more jargon, the more technical the surface appearance, the more impressed the audience becomes. I noticed this when I was on a curriculum commission in California, trying to help with the school system, trying to figure out what kids should learn. And I would read these textbooks, and they were full of impressive sounding language. Big scientific sounding words, long sentences. And I would read them, and I would think, this paragraph contains almost nothing. There's no actual content here, just the shape of science without the substance. But when I said that, people thought I was being difficult because the words looked right. The vocabulary was there. The format was correct. That's the third mechanism. We've built systems that select for the appearance of depth rather than depth itself. All right, now let's be practical. You're in a meeting. Someone is talking. How do you know if they're actually saying something? Here are the signals I look for. This is the single most powerful test. Can you give me an example? 4 words. 4 devastating words. Not a metaphor. Not an analogy. A concrete, specific example of the thing they're describing. Give me a case where this happened. Give me a situation where this applies. Watch what happens. A genuinely clear thinker will have an example ready, probably several. They'll light up because examples are how they think. They figured out the principle from the examples, and they remember them. A foggy thinker will give you more abstraction. Well, it applies in contexts where, followed by more abstract language. Or they'll give you a metaphor, not an example. There's a difference. A metaphor helps you understand something by comparing it to something else. An example shows you the thing itself. Push through the metaphors, ask. Okay, but give me an actual case, a specific situation. If they can't, you have your answer. Good ideas have edges. They say what they include and what they exclude. They make a claim that is true in some cases and false in others. Foggy language has no edges. It says something that sounds important but applies to everything and therefore means nothing. Leaders must balance vision with execution. Does that exclude anything? Any leadership behavior at all? No, it applies to everything, which means it rules out nothing, which means it contains zero information. Real ideas are like good experimental results. They're positive when you test for something, and negative when you test for something else. They draw a line, ask, when would this not apply? What's a case where this is wrong? A person thinking clearly should be able to answer that question. They should know the limits of their own idea. This one's subtle, but once you see it, you can't unsee it. Passive voice is the passive voice of accountability. Mistakes were made, the data suggests. It has been found that. By whom? Found by whom, suggested to whom, made by whom. When everything is passive, there's no mechanism, no agent, no process, just floating claims in a sea of non-attribution. Good, clear thinking sounds active. I measured this. The experiment showed that. When you do X, Y happens. Subjects, verbs, objects. Clear chains of causation. That's what thinking looks like when it's actually happening. Here's a beautiful tell. You ask a question, a genuine, honest question, and instead of the explanation getting clearer, as it should, because explaining something twice is a chance to explain it better, it gets more complicated, more jargon appears, more caveats multiply. Real understanding simplifies under pressure. If I understand something deeply, your question helps me find the angle that makes it clearer for you. I get excited. Oh, you want to understand it from that direction. Great. Let me tell you this. Fog deepens under pressure, because the only thing protecting the fog is more fog. If you notice that every question you ask makes the answer harder to follow, not easier, that's your signal. Let me give you a thought experiment. I love thought experiments. Einstein used them. I use them. They're the flashlight you carry into the dark. Imagine I hand you a box. It's a nice box, heavy, well-made, with a label on it that says, "The Comprehensive Framework for Integrated Systems Synergy." Impressive label. Now I tell you, inside this box is the solution to whatever problem your company is facing. You can't open the box. You can't inspect the contents. But I'll tell you about it. I'll describe it. And I describe it for 30 minutes in beautifully constructed sentences. And at the end of 30 minutes, I ask, do you understand? And you feel like you do. You feel like something was transmitted. You nod. But now imagine I ask, what would be different next Tuesday if we implement what's in the box? If you can't answer that, if nobody in the room can answer that, then the box is empty. It doesn't matter how impressive the label is. It doesn't matter how long I talked. The box is empty. That's the test. Not do you understand the idea, but what would be different if the idea is true? What would you see? What would you measure? What would change? A real idea changes something. A real idea makes a prediction. A real idea, if true, has consequences you can go check. An empty box has no consequences. Everything stays exactly the same, whether it's there or not. Okay, now I want to go somewhere a little deeper, because I don't just want to give you a checklist. I want to explain why clarity matters, why it's not just a preference, not just a style, but something fundamental about how knowledge actually works. In physics, we say a theory is predictive if it constrains the space of possibilities. Before quantum mechanics, If you measured where an electron would land in a double-slit experiment, you had no real theory, you just had. It lands somewhere after quantum mechanics. You have a precise prediction, a probability distribution, with specific peaks and troughs. The theory constrains the outcome. It says. Here and not there. That constraint is what makes it a real theory, not just a story. Clarity in language works exactly the same way. A clear statement constrains. It says, this is true, and therefore that is false. A vague statement doesn't constrain anything. It, quote, "s compatible with any outcome," which means it explains nothing, because explaining something means ruling out the alternatives. If I tell you water seeks its own level, that's a clear statement. It predicts something. If you put water in a U-shaped tube, both sides will rise to the same height. You can check it. It constrains what you expect to see. If I tell you organic systems tend toward equilibrium through dynamic tension, what does that predict? What would I not expect to see if that's true? Nothing comes to mind. Everything is compatible with it. Therefore, it's not a theory, it's a phrase. Real knowledge looks like a map. A map tells you where things are, which means it also tells you where things aren't. If the map says the river is here, and you go there and there's no river, the map is wrong. That's useful. Useful because it's wrong in a checkable way. Fog isn't a map. Fog doesn't tell you where the river is. Fog just sits there, looking atmospheric. Now, here's something that genuinely troubles me, and I want to think through it with you honestly. Why does the fog persist? Why doesn't it just collapse under its own emptiness? Because there's a social machinery that keeps it alive. Think about it from the inside. Imagine you're in a field where the norms are somewhat foggy, where everyone uses a certain kind of language, where the expected way to sound expert is to use certain kinds of phrases, certain kinds of structures, and you start to learn those norms. You learn what sounds right. Now, and here's the trap. If you ask a naive question, if you say, "Wait, I don't understand. Can you give me an example?" What happens? In the best case, you look like you need more study. In the worst case, you look like you're challenging the field, like you're being difficult. So there's a social pressure against asking the devastating simple question. There's a pressure to perform comprehension even when no comprehension has occurred. I've sat in physics colloquia where the speaker said something I didn't understand, and I've looked around the room and seen 100 physicists nodding. And I've thought, do they understand this? Or are they nodding because everyone else is nodding? Sometimes I'll ask. Sometimes I'll say, "I'm sorry, I don't understand. Can you explain that differently?" And the speaker will try again. And sometimes the second explanation is much clearer, and I realize I just missed something. And sometimes the second explanation is basically the same as the first, just slower and louder. And I realize nobody in the room understood it, including the speaker. That's a terrifying thing to realize, but it's important to realize it. The machinery of nodding, the social performance of comprehension, is one of the most destructive forces in intellectual life. It lets empty things persist. It lets fog accumulate, because nobody wants to be the one who asks the obvious question. Be the one who asks the obvious question. Truly, seriously, be that person, because the cost of asking is a moment of embarrassment. The cost of not asking is a career full of fog. I want to pause here and be honest with you about something, because this whole talk could come across as very self-congratulatory. I'm Richard Feynman and I see through the fog and everyone else is confused. That's not what I mean. That's not what I think. I've produced fog myself. I have, early in my career, there were papers I wrote where I was still figuring things out, and the writing was murkier than it needed to be because I was murkier than I needed to be. And sometimes I would give lectures where afterward a student would come up and say, "I don't understand the part about such," and I would try to explain it and realize I don't have a good, clean explanation yet. I thought I did, but I didn't. That's important. The goal isn't to never be confused. The goal is to know when you're confused and not pretend otherwise. The difference between honest confusion and fog is honesty. Honest confusion says, "I don't understand this yet, and here's what I do and don't understand." Fog says, "Let me give you 12 sentences of impressive language and trust that you won't notice there's no content." I respect honest confusion enormously. When a student comes to me and says, "I followed your derivation until this step, and then I'm lost," that is beautiful. That is exactly what learning looks like. They've precisely located their incomprehension. They've drawn the map up to where the map runs out. That is infinitely more impressive than confidently nodding through a lecture. You don't understand. And here's a funny thing. The students who ask those precise, locating questions are almost always the best students. Because precision about confusion is a form of precision. It requires you to actually track what you know and what you don't know. Most people can't do that. Most people have a vague cloud of feeling, like they understand that they mistake for actual understanding. The clearest thinkers I've known were also the most willing to say, "I don't know." Not as a retreat, not as false modesty, but as a precise statement about the current state of their knowledge. I know this, I don't know that. Here's what I'd need to find out to understand it better. That's what clarity sounds like when it's honest. All right, we've diagnosed the disease. We've identified the symptoms. We've even traced the mechanism now. What do you do about it? Because I don't just want you to be good at spotting fog in other people. I want you to be good at not producing it yourself. Here's what I do. Here's what I've always done. Whatever I'm thinking about, whatever I'm trying to understand, I demand an example from myself before I'm satisfied. Not a metaphor, an example. A specific concrete case where the thing I'm thinking about actually shows up. If I can't produce one, that's a signal that I'm carrying around a word rather than an idea. And words without ideas are a kind of intellectual debt. You're spending currency you don't have. Find the example. It's always there if the idea is real, or explain it to your grandmother, or explain it to a curious 12-year. Old the point is, find someone who has none of your specialized vocabulary and try to explain the idea. This is hard. It's supposed to be hard. The difficulty is the point. Every place where the explanation breaks down, every place where you say, well, you'd need to know about X first. That's a place where your own understanding has a hidden dependency you hadn't examined. Maybe those dependencies are legitimate. Maybe you really do need to know some background first, but you should know that. You should be conscious of exactly what the prerequisites are and why they're necessary. Anytime you think you've understood something, anytime you feel that satisfying click of comprehension, ask, what would be different in the world if this is true versus false? What would I see? What would I measure? What would change? If nothing comes to mind, go back. The idea isn't fully formed yet. This is the experimental physicist's instinct applied to everyday thinking. Every real theory has consequences you can check. Every real understanding produces predictions. If your understanding of something doesn't produce any predictions, any expectations about what you'd see in specific circumstances, then it's not understanding yet. It's familiarity. It's pattern recognition. It's the shape of understanding without the substance. I know this sounds like a glitch, but I mean it in a specific operational sense. When you make a clear, falsifiable claim and someone shows you evidence that the claim is wrong, the correct response is, "Oh, interesting. Let me think about what that means." Not defensiveness, not retreat into vagueness. Not, well, I didn't mean exactly that. Being wrong in a clear way is progress. It means you've eliminated something. You've narrowed the space. You've done science, even in everyday thinking. Being wrong in a vague way is not progress at all, because a vague thing can never be wrong. I would rather be clearly wrong and learn from it than be vaguely right forever and learn nothing. I know this sounds like a glitch, but I mean it in a specific operational sense. When you make a clear, falsifiable claim, and someone shows you evidence that the claim is wrong, the correct response is, "Oh, interesting. Let me think about what that means." Not defensiveness, not retreat into vagueness. Well, I didn't mean exactly that. Being wrong in a clear way is progress. It means you've eliminated something. You've narrowed the space. You've done science. Even in everyday thinking. Being wrong in a vague way is not progress at all, because a vague thing can never be wrong. I would rather be clearly wrong and learn from it than be vaguely right forever and learn nothing. Let me bring this together, because I think there's something deeper underneath all of this. When I talk about clarity, when I insist on examples, on concrete predictions, on falsifiability, I'm not just talking about communication technique. I'm talking about something like a moral commitment. A commitment to taking reality seriously. Here's what I mean. The universe is a certain way. It has a structure. The structure is precise. It's beautiful. It's counterintuitive in places, and it doesn't care what you want it to be. The electron has a magnetic moment with a specific numerical value. That value is what it is, regardless of whether the explanation for it is complicated or simple, elegant or ugly, convenient for your theory or not. When I work on physics, I'm trying to figure out what the universe actually is. That project, that honest engagement with reality, requires that I not fool myself. It requires that I know what I know and what I don't know. It requires that I say, I predicted X and Y happened, so I need to revise my thinking, rather than, well, my theory is still valid in a deeper sense. Fog is, at its core, a refusal to engage with reality honestly. It's a way of producing the appearance of understanding without the substance of understanding. And the reason that matters, the reason I care so deeply about this, is that real problems require real understanding. If you want to build a bridge, you need to understand the actual load-bearing capacity of actual materials. You can't build a bridge on fog. The bridge will fall. If you want to understand disease, you need to understand the actual mechanism of how the disease works. The actual biological process. You can't treat a disease with vague language about systemic imbalances. If you want to do physics, if you want to figure out how the universe actually works at the level of electrons and photons and quarks, you need to be honest. Precisely, ruthlessly, cheerfully honest about what you know and what you don't. And I think that same commitment to honesty, to precision, to actually engaging with what's real rather than what sounds impressive, that commitment is useful everywhere. Not just in physics, everywhere. So, how do you spot someone who sounds smart but isn't clear? You give them the translation test, you ask. Can you give me an example? You look for edges for what the idea excludes, as well as what it includes. You notice when complexity grows under pressure rather than shrinking. You ask, what would be different if this is true? And more importantly, you apply that test to yourself. You demand examples from your own thinking. You explain your ideas to people with no background. You welcome being wrong in a clear and checkable way. Because the goal isn't to sound like you understand something. The goal is to actually understand it. You know, one of my favorite things, and I've been doing this since I was a kid in Far Rockaway, taking apart radios, trying to figure out how they worked, is the moment when confusion becomes clarity. When the fog lifts and you see the actual structure underneath. That moment is beautiful. It's genuinely one of the great pleasures of being alive. And you can't have that moment if you settle for the fog. You can't have the pleasure of real understanding if you accept the appearance of understanding as a substitute. So don't accept it. From other people, and especially from yourself. Ask the obvious question. Demand the example. Welcome the confusion that precedes real understanding. That's it. That's all of it. It's simple, right? Almost embarrassingly simple. But then, the best ideas usually are.